Hello students, myself Dr. Sujata Kulhe. In this video, we are going to study the intelligent agents. We are going to discuss what is the nature of agents, what are the diversity of environments and the resulting agent types. Previously, we have seen what do you mean by rational agents, and we also have seen what do you mean by rationality. We are going to use this concept to develop a small set of design principles for building successful agents and systems that are reasonably be called as intelligent. We will begin with examining the agents, environments, and how do they interact with each other. Agents. An agent is anything that can be viewed as a perceiving its environment through sensors and acting upon that environment through actuators. So here, what do you mean by agent that we'll see first? We have already seen that agent is an entity which is going to act in the environment and which is trying to achieve the desired goal. Now here, what is an environment? What are the sensors and what are the actuators? To understand this, we will see an example of human agent. Like humans have ears, eyes, skin for sensing purpose. So the ears, eyes and skin are the sensors for human agent, which will sense or which will perceive from the environment. Similarly, humans have hands, legs and mouth, other body parts as an actuators. They are going to act in the environment. Like suppose if there is a stinky smell, in that case your nose will sense and it will act as a sensor, and automatically your hand will be put on your nose. So hand will be an actuator. Next example we'll see of robotic agent. Robotic agent has cameras and infrared range finders as a sensor. Using the camera, they can perceive what is moving or what is going on in the environment. Infrared range finders will find out how far the object is from the robot. So these are various sensors used in the robotic agent. After that, now how the robot is going to act in the environment. So robotic hand is there, for which various motors are required to run particular action. So various motors will act as an actuators. Next agent we can see software agent. Software agent, we have keystrokes, network packets and documents as an sensors, because the software agent will sense from a key. It will detect what is the message using a network packet. It can find out which document is there and what document to be read. So these are the sensors, and it will display accordingly a message onto the screen. Similarly, suppose it has to take a certain action. So the functions which will act as an actuators. So this is what is an agent. Now here we have used a term perceive, or we use the term percept. Percept term is used to refer to the agent's perceptual input at any given instant. An agent's percept sequence is a complete history of everything the agent has ever perceived. That we are going to see. Now, here, the agent is an entity which is going to work here, right? Agent has various sensors, we can see, and agent has actuators, that is the hands and legs. Consider this as an robotic agent. It is going to perceive from the environment. This is the environment. Consider it as any environment you can consider for which this robot is designed. So from this environment, the robot is going to perceive. After pursuing, it will make an action, or it will think what should be an action, and that action is taken into an environment. So this is your perceiving and action. Now, as we have seen that there is a percept history. So a percept history is nothing but a percept sequence, and the agent's choice of action at any given instant can depend on this entire percept sequence observed till now. That is the percept history. So we are here to design an agent function that will map the percept history into the desirable actions. We can see that P star stands for your percept history, and percept history, after perceiving the history, the agent is going to act in the environment. So A stands for your action, and this is what is the function, agent function, which will match the percept history to the action. Now, what is an agent program? Agent program runs on the physical architecture. That is, agent program will actually run in this physical environment to produce the F. So, the agent is equal to architecture plus program. We can say that an agent's behavior is described by the agent function that maps any percept sequence to an action. To understand this, we will see an example of vacuum cleaner world. Consider there is a vacuum cleaner placed over here. Actually, there are two rooms, A and B. Two rooms are adjacent to each other. In A room, vacuum cleaner is placed. Some dust is there in A room as well as in B room. Now here, what the vacuum cleaner is going to do? So, vacuum cleaner will perceive what is in my surrounding. So, the vacuum cleaner will perceive that there is a dust. So, the vacuum cleaner will automatically reason out that if there is a dirt, in that case, what I should do. So, here two things are there. First is what is the percept and what are the actions. Now, the percepts are location and contents. That is, the vacuum cleaner will first sense from the environment that in which room it is present, that is the location, and is there any dirt or not. So these two things the vacuum cleaner has to sense. Corresponding actions are left, right, suck and no up. That is, the vacuum cleaner will sense if there is a dirt or not. If there is a dirt, in that case it will suck that dirt. Now it will sense if there is a dirt or not. If there is no dirt, in that case it will sense in which box it is or in which room it is. If it is in A room, then it will shift to right or it will move right. After moving to right, it will sense whether there is a dirt or not. If there is a dirt, then it will suck. After that, it will sense in which room it is. If it is in room B, in that case, it will move to left. After doing many times these things, if both the room remains clean, in that case, the vacuum cleaner will perform no operation. We can imagine tabulating the agent function that will describe any given agent. This is what is an table in which we are going to store the percept sequence and the corresponding action. What is an agent function here? If the current square is dirty, then suck. Otherwise, move to the other square. Here, the table is of course an external characterization of the agent. Internally, the agent function for an AI agent will be implemented by an agent program. It is very important to keep these two ideas distinct. What is an agent function and what is an agent program? So the agent function is an abstract mathematical description and the agent program is a concrete implementation running on this architecture. The partial tabulation of this agent function is given in this table. Now here we have already seen that if the vacuum cleaner is in the A location and if the A location is clean, in that case it has to move to right. If A is clean, then move right. If the vacuum cleaner is present in A room and if it is dirty, then the action would be suck. If the vacuum cleaner is in B and the room B is clean, in that case vacuum cleaner agent has to move to left. Here we can add two percept sequences also, like if room A is clean and if room A is clean, in that case the vacuum cleaner has to move right. Also, if room A is clean and if room A is dirty, in that case the vacuum cleaner has to suck the dirt. Now we see that various vacuum world agents, that is the vacuum cleaner agents, can be defined by simply filling the right hand column in various ways. That is by simply filling the actions in various ways. The obvious question then is that what is the right way to fill out the table? What is the right way to fill out this table? Or what makes an agent good or bad? Whether the agent is intelligent or stupid. In simple word, we can say that how the user will be, or if the user will be happy after using this vacuum cleaner agent or not. And here the concept of performance measure arises. Now here the concept of rationality is also important. So what is an rationality? As we have already seen that rationality refers to making the correct decision. And what is an rational agent? An agent should strive to do the right things based on what it can perceive and the actions it can perform. The right action is the one that will cause the agent to be the most successful. So, the agent is going to be the most successful if it is making an right action after perceiving from the environment. If the agent is most successful, in that case the agent is performing well. Sometimes this happens that the right action is the one that will cause the agent to be most successful. But we need some way to measure this success. And this is what is your performance measure. Performance measure is an objective criteria for success of an agent's behavior. The performance measure embodies the criteria for success of an agent's behavior. When an agent is plunked down in an environment or when an agent is working in the environment, it generates a sequence of actions according to the percept it receives. Now here, the actions according to the percept is received may vary depending on an environment. This sequence of action causes the environment to go through a sequence of states. That is, the agent can have multiple states. If the sequence is desirable, then the agent has performed well. Obviously, there is not one fixed measure suitable for all agents. Naturally, if the vacuum cleaner is working in A environment, the set of actions would be something different than the vacuum cleaner which is operating in environment B. We can ask the agent for a subjective opinion of how happy it is with its own performance. But some agents would be unable to answer and some other would deduce themselves. Therefore, we will insist on an objective performance measure, typically one imposed by the designer who has designed or constructed the agent. We will consider again an vacuum cleaner agent. Now vacuum cleaner agent here could be amount of dirt cleaned up. So one of the performance measure would be how much dirt it has cleaned. One of the performance measure may be amount of time taken, that is how much time it has taken to clean the dirt. Now it also depends on what type of dirt it is. So you can design various performance measure like how much amount of time it has taken to clean the dust and how much time it has taken to clean the dirt which consists of small pieces of paper or some shield pencils and all. Also, one of the performance measure can be the amount of electricity it has consumed. The one important performance measure is how much noise it has generated. So, these are the example performance measure of a vacuum cleaner agent. If the vacuum cleaner agent has cleaned the dirt, if it has taken less time, it has consumed less electricity and it has generated less noise, in that case the user will be happy and you can call it as an rational agent. As a general rule, it is better to design the performance measures according to what one actually wants in the environment rather than according to how one thinks the agent should behave. It is not important that how the agent should behave, but it is very important that how actually it should act in the environment. The definition of cleanliness may vary person to person. So that's why you have to define the performance measure based on for what purpose the rational agent is designed. So one definition for rational agent is, for each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. This is very important. The rational agent should act rationally, but given the evidence, that is how it has generated the percept sequence and what is its built-in knowledge, based on that only the rational agent is going to work. Now, the rationality is different or it is distinct from an omniscience. What is an omniscience? Omniscience is all knowing with infinite knowledge. Now, what is that? The omniscience agent knows the actual outcome of its actions and it can act accordingly. But omniscience is impossible in reality. To consider this, we will see an example. Suppose you are crossing the road. Suppose you are going through the road and on the other side of the road you saw your old friend. Now you decided to meet to him. So you started crossing the road. Meanwhile, a huge sound is heard. A cargo door falls off a passing airliner. Therefore, before you make it to go to other side of the street, you got flattened over there. Were you irrational to cross the street? This is the obvious question. Now, in this example, it shows that the rationality is not the same as perfection. The rationality maximizes expected performance, while the perfection maximizes the actual performance. Right. Now, using this example, you can understand that what is an omniscience and which is sometimes impossible here. One more example we can take that if an agent does not look both ways before crossing a busy road, then its percept sequence will not tell that there is a large truck approaching at high speed or not. Right? So this is what is the omnidirectional science is required over here. Second is a rational agent should choose the looking action before stepping into the street because looking helps maximizes the expected outcome. Now next is here information gathering. Now what do you mean by information gathering? Doing actions in order to modify the future percept is sometimes called as information gathering, which is also an important part of rationality. So the rational agent always try to gather the information in order to make an rational action. Also, second term is important, that is exploration. Exploration that one must be undertaken by a vacuum cleaner agent in an initially unknown environment. That is, whenever a vacuum cleaner is placed in an unknown environment, it is totally new to the environment. Whenever it is sensing, initially it will face difficulties in sensing. But later on, easily it can sense because it is habitual to that environment. So exploration is also important. Also, to the extent that an agent relies on the prior knowledge of its designer rather than on its own percept, we say that the agent lacks an autonomy. That is, the agent is autonomous if its behavior is determined by its own experiences, not the knowledge which is fed by the designer. An agent can be autonomous with the ability to learn itself and adapt to the new circumstances. These are the important terms related to the rational agent. We have already seen what is an rationality and what do you mean by rational agent. But we must think about the task environments which are important or which are essentially the problems. to which rational agents are the solution. We will start by showing how to specify a task environment by illustrating the process with number of examples. Now we will consider that, or we can show that the task environment comes in variety of flavors, and the flavor of task environment directly affects the appropriate design of the agent program. Now how is this possible? We'll consider our typical vacuum cleaner agent example. Suppose a vacuum cleaner agent is placed in the rooms which are very much windy rooms. The windy rooms can collect variety of dirt. That is, it can collect the dust, it can collect small particles of the traffic. Also, it can collect the small pieces of the paper and other dirt. So, the working of an environment or the task environment is different of this particular vacuum cleaner machine, vacuum cleaner agent. In contrast to this, suppose a vacuum cleaner agent is placed in a room which is placed in the cold area where there is no dirt, no piece of papers and no small traffic dirt. Now here, will the environment, the performance measures, the actuators and sensors would be same for both the vacuum cleaner agent? Definitely not, because both the vacuum cleaner agents are having different task environments. So this particular task environment is going to change the design for the agent program. Whenever we are going to design an agent program, we have to specify what are the performance measures, the environment, the agent's actuators and sensors. We will group all these together under the heading of task environment. For the acronymically minded, we call this as an piece description. So this is what is your piece description. P stands for performance measure, E stands for environment, A stands for actuators and S stands for sensors. So whenever you are going to design an agent, in that case you have to define the task environment in terms of this piece. To understand the piece properties for an agent, we are going to consider a famous example of automated taxi driver agent. Automated taxi driver agent is designed to drive a car automatically, that is, without the help of the human being. Now, what would be the piece description for such an agent? First thing is, we'll see what is the environment in which the agent is going to work. So, as it is a taxi, obviously the environment would be roads on which the taxi is going to drive. We know that in the environment not only one taxi is there, other traffic is also there, that is other cars are also driving. So it is considered as an other taxi or other traffic. Now we know that whenever we are going through the road, pedestrians are also there which are crossing the roads or they are walking through the road. So pedestrian is also an environment. Customer is also an environment. Then the climatic condition, that is the climate, whether it is windy, whether it is raining, whether it is sunny. So the climatic conditions are also considered as an environment. The trees, the gardens, the lakes, all this can be considered as an environment. Now, what may be the sensors? That is, for designing an taxi driver agent, what sensors you need. Now, what is the objective of an automated taxi driver agent? The objective of automated taxi driver agent is to drive the taxi automatically, safely to a particular destination. For this purpose, what we need, what can be the sensors through which the taxi driver agent would sense? So, cameras are there. Cameras are used to sense what is going on in the surrounding. Then sonar are there to detect whether there is a sun rays or not. Speedometer is there to sense what is the speed of my car or what is the speed of the taxi. Is it too fast or too slow or like that. GPS is there which is used to find at which path we are, that is whether we are on the right path or not. Some engine sensors are there which automatically sense some important information which is required to drive the car. Odometer is also one of it. Sometimes if your car is having built-in system, in that case you need a keyboard through which you can give the information. Sometimes voice assistant is also there in your car. So voice assistant can be also considered as an sensor. Now, what may be the actuators? Actuators are going to act in the environment. So what is going to act in the environment? So a taxi is driving in the environment. To drive that taxi, first we need to have a steering wheel. So steering wheel are required to move to left or to turn to left or right or to be straight. Accelerator is required to adjust the speed of the taxi. Suppose somebody has come or some obstacle is there, or suppose an speed breaker comes across, in that case you need to apply the brake. So brake is one of the important actuators in automated taxi driver agent. Suppose you want to move or you want to take a U-turn or you want to turn to right. In that case, signaling is very important. So signals are there which will act in the environment to indicate that you are turning to right or left. Suppose somebody comes in between, in that case, to indicate that you have become an obstacle in driving, the agent has to act in the environment by honking. So horn is required for that purpose. Now after seeing the environment actuators and sensors, we'll see what are the performance measures. How happy you will be after using an automated taxi driver agent. So you will become happy or you will be satisfied if the automated taxi driver agent drives safely. So safety is the performance measure. Now, if the automated taxi driver agent is driving too fast and it is not comfortable trip. Now, what do you mean by comfortable trip? Suppose it is driving very harsh. It is not looking at whether there are speed breakers or not, and it is driving harshly. In that case, you won't feel comfortable in the taxi. So comfortable trip is one of the important performance measure for which where the speed is also important. Whether it is legal or not, this particular automated taxi driver agent is registered somewhere or not. That is the legal. Maximizes profit, that is if my agent is going to give me the good profit, in that case it would be a good performance measure or it is a good taxi driver agent. Apart from this, if your taxi driver agent is going to reach at a particular destination, in that case that can be considered as a performance measure, that is correct destination you can say. Also also how much time it is taking to reach to the destination, that also matters here. So that is also an important performance measure in the taxi driver agent. Now you might have understood that what are the various piece descriptions which are required for automated taxi driver agent. We will be going through various other agents for which the piece description is given. The next case study we are going to see is the medical diagnosis system. In the medical diagnosis system, the patient or the customer has to feed what are the symptoms. In that case, the medical diagnosis system will give you the treatment. Now, what can be the performance measure for such a system? So, first performance measure is healthy patient. Or before seeing at the performance measure, first we'll see what is an environment for such a agent. Definitely, as it is a medical diagnosis system, in that case, the definite environment would be your patient. Next is hospital. That is where the patient would come and the medical diagnosis system agent can actually see the patient. Similarly, we require other office staff or other hospital staff also to assist the medical diagnosis system. Like nurses are there or compounders are there to take care of the patient or to take that particular patient to for a particular screening or like that. So staff is an environment here. Naturally, the rooms in the hospital or other climatic conditions are there, that is there in the environment. After that, what may be the sensors? Now, you consider medical diagnosis system as an robotic system. So naturally, it should have certain sensors to sense the patient. Suppose it is a system which is going to take the symptoms of that patient. So for entering the symptoms of that patient, we require a keyboard through which an agent is going to sense what are the symptoms. Based on that symptoms, if findings are there, then those findings can also be a sensor to such a agent. Sometimes this medical diagnosis system will ask some question to the patient. In that case, the patient would answer it. So you can consider it as an Arogya Setu app or chatbot. In that, the Arogya Setu app is asking you what are the symptoms, whether you have been through the cold or cough, what is the severity of it, whether you have met the people who are already corona infected, etc. So such a kind of chatbots may be there, and in that chatbots the system or the agent is going to ask the question to the patients and the patient is going to respond. So the response may be the one of the sensor. Now to do all these things, the agent needs to act in the environment. So actuators are there. So what can be the actuators for such a agent? So whatever questions we have seen, questions can be an actuator. So to display that question, we require a screen display. Any screen you can consider here. So also after that, some tests are there. Like if the medical diagnosis system wanted to know what is the level of hemoglobin in the patient. In that case, it will suggest some test for that patient. So test will be considered as an actuators. Diagnosis also can be an actuator. That is, this is what is the diagnosis of your disease. Then according to that diagnosis, it is going to give you the tablets or injections or medicines. So that is called as your treatments. So treatment is again one of the actuator here. Now based on this, some referrals are there. That is, suppose the agent has referred to another doctor. Suppose the agent has referred to the hematologist. In that case, that referrals would also be an actuators. Now we have seen what is an environment, what are the sensors and what are the actuators. After using all these things, if your agent is perfectly working, in that case you can measure what is the performance of your agent. And if it is accepted performance, in that case you can say that your agent is a rational agent. Now, what can be the performance measure here? Obviously, the patient should be an healthy. That is the motto of the medical diagnosis system. Next performance measure can be to minimize the cost, because it should be economical for everyone. So that's why to minimize cost is very important performance measure nowadays. Lawsuits is also one of the important performance measure, because many this particular medical diagnosis system, whether it is suggesting medicines which are according to the diagnosis or not, whether it is following various laws, rules and regulations which are required for a particular hospital or for a particular doctor. So whether if it is following that laws or not, that is important performance measure. So these are the piece descriptions for medical diagnosis system. We will move to the next case, that is part picking robot. So the agent is part picking robot, and the robot has to pick the part which are bad or faulty parts, right? Now here, what can be an environment, that we'll see first. Naturally, the environment in the factory, suppose, and robot has to pick up the parts which are damaged or faulty. In that case, in the factory, there are conveyor belts. On that conveyor belts, the part would come after manufacturing. Now here, a robot is placed to pick up the correct part, and it has to deposit that correct part into the respective bins. So a conveyor belt with part is there. Then correct beans are there which are put over there or which are arranged near this conveyor belt. Apart from this, whatever typical factory environment, that is the switches or big rooms or some material, the machines, all that comes under your environment. Now, what may be the sensors? The sensors may be the cameras. Cameras are required to check which part is what. That is to sense what is going on in that conveyor belt. So camera is important here. After that, joint angle sensors are there which are going to sense what part it is. That is, what is the shape of that part and what is the fabric or touch of that part. Based on that, it is going to sense what part it is. Now, according to that, the actuators are developed. So the actuators are the things which are going to work in the environment. So what may be an actuator here? The actuator is jointed arm and hand through which the robot is going to pick up the part and it is going to put it in the particular bin. So this is what is an actuator. Apart from this, the actuators may be some alarming sound. Suppose by mistake it has made or it has put a wrong part in a particular bin. In that case, and it realized, in that case it will siren. So that may be also an actuator here. Now, what are the performance measures here? Naturally, the performance measure is percentage of parts in correct bins. That means in whether the correct parts are been placed in the correct bin or not. And what is the percentage of it? That is, if the 100% parts are been kept into the 100% correct bins, in that case the robot has worked fine. Apart from this, you can add other performance measure also, like how much of the power the robot has consumed, or whether it is making the noise or not, how much time it is taking to do all these jobs, whether the robot is efficient or not, what is the cost associated of this robot. So these can be an extra performance measures which are not mentioned here. The next piece description or the next case study we are going to consider is interactive English tutor. Now, in this case, we all are aware that this corona has led us to the situation where everyone is going to the online classes, and here it is very important to develop such an agent which may work or which may act interactively to teach the English. So this is one of the agent case study we are going to see. What may be the environment here? Now, the environment may be the students, right? Now, if it is an online education, in that case, whatever environment, typical environment, internet, your laptops, your mouse, then keyboards, and whatever things are there, those would be their environment. And suppose if it is a offline environment, or if it is a offline interactive English tutor, in that case the environment would be the classroom, students, benches, your projectors on which you are going to teach, and typical environment of the classroom can be there. Now, what are the sensors? The sensors would be keyboard here, through which the interactive English tutor is going to sense what the student has written, or what the students is saying. So the students are saying through the keyboard, or they are going to give you the input through the keyboard. So the sensors would be keyboard here. Or suppose if it is a offline, in that case the sensors, sound sensors would be there, which would listen to the student query. In that case you require NLP also to understand what is natural language, or what is the semantic of that question and all. So that can be a sensor, sound sensors. In case of online, it is only just a keyboard or files or document. What may be the actuators? Now, actuators are the thing which are going to act in the environment. So if it is a online environment, in that case screen display or streaming of your screen can be an actuator here, through which you can give the exercises, you can make the corrections in your assignments, and you can suggest some extra experiments or some questions for study. Suppose if it is an offline, in that case the agent is going to speak in front of you. It is going to give you the assignments, it is going to show you the questions on the projector, etc. Now, what are the performance measures? Performance measures, as we have seen, are the measures through which you will come to know that whether you have designed a good agent or not, whether the agent is rational or not. So what are the performance measure? So the important performance measure is maximize student score on the test. That is, it will define you what is the quality of the English tutor, because if the student is going to score maximum in the test, in that case it understood well the concept of English. So if the student is going to score good in your examination, then you can say the agent has performed well. This is one of the important performance measure. Along with this, you can consider how much of the time the English tutor has taken to teach a particular material. After that, you can say that how much of this speed it is maintaining while delivering the lecture or while teaching. Also, how much fees it is taking to teach a particular course. So all these can be an performance measures here. We are going to see various other agents for which what are the performance measures, environments, actuators and sensors. One of the common agent is robot soccer player, which is going to play a soccer. What would be the environment here? the fields, ball, his team, other team members, his own body. These may be the environment to require to play the soccer. Now, what may be the sensors? Camera to sense where exactly the ball is going. Touch sensor, who exactly or to sense what is the touch of that ball. Accelerometer is there to identify what is the speed of that ball. Orientation sensors, that is in what orientation he should play or make a shot. Then wheels to move around. What may be the actuators? Various devices, that is the legs for locomotion and kicking. That is, the agent is going to kick the ball. So for that purpose, the specific legs and their motion is required. That may be the actuator here. What is the performance measure then? Obviously, making goal. And if the agent is making more goals, in that case, winning that game. This may be the robot soccer player agent. Next is your internet book shopping agent. An internet book shopping agent would automatically book or it will automatically shop for you. Okay. So what may be the environment here? So environment may be an internet browser, your laptops through which you are entering what items you want or which books you want. So typical internet environment would be there. What may be the sensors? As the agent is going to sense through the web page, that is, it is going to take the input from the environment in the form of web pages. What is the user request that it is going to sense? So these may be the sensors here. After that, what may be the actuators? That is how the agent should act in the environment. So follow that link, enter or submit the data in the field, then display the books to the user. These may be the actuators. Based on this, what may be the performance measure? So obtain requestioned or interesting books. That is, if the agent is able to shop for you an desired book or interesting book, in that case you will be happy. Also minimize the expenditure, that is the cost is also important. So also you can add speed of that agent, and cost of that agent is already we have covered. So speed may be the performance measure. Next agent we are going to consider is autonomous Mars rover. For the designing of autonomous Mars rover, what may be the environment? The environment may be obviously the Mars, the land on the Mars. Then you need a launch vehicle over there to move around the Mars. Then you require a lander which would land that rover onto the Mars. The typical environment of the Mars, that is climatic conditions, would be there as an environment. What may be the sensors? Cameras are there to sense. Then touch sensors are there for sensing the touch of that material or whatever things they have to collect. Accelerometers and orientation sensors are required, in which orientation the rover should move. Then wheel or joint encoders are required to make a movement. Then radio sensors are there through which it can sense what may be the next action, or if it has any certain instruction, in that case it would sense it through the radio receiver. After sensing all this information, what it should do? So it should move on the or around the land or whatever things are there on the Mars. So you require wheels or legs. Then a sample collection device is required, because the goal of the Mars rover is to collect some samples. So to collect that sample, you require a device which would collect it. Then analysis devices. That is, to analyze that sample, you require the actuators which are going to analyze that samples. To send that report, we require a radio transmitter which is going to transmit the report of collected samples. These are the actuators. Now, what may be the performance measure? The performance measure may be terrain explored and reported, whether it has correctly collected the samples and it is reported or not. Also, number of samples which are gathered and analyzed in a particular time. That may denote you what is the speed of that rover and efficiency of that rover. These can be the performance measures here. So, we have studied in this chapter what do you mean by an rational agent, how do you design a rational agent, that is, what is an rational agent function and program. After that, we have seen what are the different piece description for the task environment, and we have gone through various case studies through which you can understand what are the piece description you have to consider while designing an intelligent agent. Thank you very much for patiently listening.